Today we're going to be talking about 3.3 stem and leaf plots. Now stem and leaf plots are one way that you can take some information and basically show where the data is clustered. Before I do an example, I want to go ahead and talk to you about some terms. Just like a plant, there's going to be a stem and then there's going to be a leaf. And you can kind of see that like I've got over here in my picture right there. You can see the stem where it's growing up and then the leaves that are going off to the side. So today I just want you to think about that picture over there when we're talking about the stem and leaf plot. The stem is going to be either the number that's in the tens place or the whole number. And now I want you to make sure that you've got your 3.3 notes that I handed out in class and go ahead and fill this in. You're going to write each stem one time. You will never write the stem more than one time. Now let's talk about the leaf. The leaf is going to be the number that is either in the ones place or it will be the numbers that are after the decimal point. Now in the blanks, I want you to write this down. Write every time that the leaf appears. Okay, so you're going to have it sometimes more than one time depending on what your data is. And then one thing that is very, very important to remember, every stem and leaf plot must have a key. And I'll explain that to you in our first example of what that means that when you need to have a key. The instructions here are asking us to make an ordered stem and leaf plot of the data. The key word that I want you to see here is ordered. Because it says ordered, that means that we have to make sure that these are in order. So just like it is that we did with the mean, median, mode, and range, we always put our numbers in order from least to greatest. So I want you to go ahead and take a minute, pause the video, and try to put these numbers in order from least to greatest. Okay, remember as you're going through, you want to always see, okay, 32 here is going to be the smallest one, so I'm going to stick it directly underneath that first number. Then the next step is going to be 39, so cross it off and stick it directly underneath the next number. Remember, having nice, neat work is huge in math, so try to stay as neat as you can. Next up, we know that we're going to have the number 40, then 43, 45, 47, 50, and then finally the biggest one is 70. Okay, so once again, please make sure every single time you always put them in order from least to greatest. Now what we have to do is we have to figure out whether or not this is the kind of number that has a tens place and a ones place, or if it has a whole number and decimal points. As I look over all of my data here, I can see there is not a single number that has decimal points. So instead, what we're going to be separating today is the tens place from the ones place. So what you're going to have is a line that you'll draw right here, separating the tens place and the ones place. One thing you want to remember is just like that plant that you see on your notes right there, there's always one stem and then there can be many different leaves. Okay, so the stem is going to be the number that all of the leaves have in common. So I want us to go ahead and look at this first number right here, 32. As you can see out of that, the tens place is the 3, so I'm going to go ahead and put the 3 to the left of my line, and then the ones place is the 2. So if I was just to look at this number right here, if that line wasn't in between it, it looks like the number 32. Okay, so that does mean the number 32. Now I have labeled and put that into my data. The next number that I have is 39. As you can see here, it's still sharing the same stem. So I am not going to come down here and rewrite the stem because remember, it shares the stem. So now I still have 3 in the tens place and I have a 9 over here in the ones place. Okay, so now as I look at my data, those are the only two numbers that have the same stem of the 30 in the 30s family. So now I'm going to go on to the next one. You can see when I come here to the 40, I'm going to go ahead and write this underneath it, 4. And then you're going to go ahead and see, okay, there are 0 ones. Going to the next one, 43. I do not have to rewrite my stem because it's already there. So I've got 43. Next up, 45. And the last one for the 40s family is 47. Remember, once again, the stem that is over here on this side is telling us that it shares the leaves on the right-hand side. So just remember, this means 40. Once again, this would be 43, 45, and 47. So you can kind of see that there was a lot of information or data there that was kind of clustered in the same exact spot. Next up, my number is 50. So once again, the tens place goes to the left, and there are 0 ones for that number. Let's go to the next one. My final number is 70. Now I want you to look over here at my stem. You can see it says 3, 4, 5, and 7. You have to count these numbers by ones, and if you look there very carefully, you can see there is one number that we are missing, 3, 4, 5, 6. It should have had a 6 right there. So I'm going to go ahead and get rid of this, and we are going to put in our 6. Now if I come back up here to my original data set, I can see as I look at all of these numbers, there are no numbers that come there in the 60s family. So some people, what they would try to do is to stick a 0 there. However, if you remember, this right here would mean that we have the number 60 in our data set. But if you look back up here at the top, there is no 60 up there. So you are not going to put anything there in this blank right here. It will just be left as nothing, and that tells us there's nothing in the 60s family. Then I can do my next one, which is 70. I know there are 7 tens and there are 0 ones. Once again, remember, you've got to go back down your stem and make sure you're counting by ones. 3, 4, 5, 6, 7, and that makes sense. If you remember, up at the top of your notes, I had something in bold, and there was a little star there, and it said, every stem and leaf plot must have a key. All right, so your key is basically the way that you can interpret, and you can tell that what I'm doing here is I am talking about the ones place and the tens place. So you can use any number that you want here. For me, I'm going to go ahead and look at this number right here. When you look at that, if you remember, it is a 32, okay? So for me, I'm going to go ahead and write down here, key. Basically, if you see that there is something that has 3 and then it has that line and a 2, that means you're just going to stick an equal sign there. That means that that is a 32. Then what you want to do each time is go ahead and box your key in. So this is how you do a stem and leaf plot. I'm going to go ahead and do one more example. If you remember from your notes, it did say that the stem could be in the tens place, but it also said the stem could be a whole number. It said the leaf could be in the ones place, which is just like our example we just did, but it also says the leaves could be the numbers after the decimal point. So for example 2, we're going to talk a little bit about what you would do if you had a data set that had decimal points. So for the second data set, you're going to do the same exact thing. Once again, it's still asking us to make an ordered stem and leaf plot of the data. So what you got to do is figure out which one is the smallest one. So as I'm looking at this data, I can see 84.3 is the smallest piece of data there. So once again, put it directly underneath the number that's above it. Up next, we're going to have 87.5. After that, you want to do the 89.4. 89.7, 90. Now when I look at 90, it seems a little different than everything else. Can you guys tell what is different about the number 90 than the rest of them? Okay, everything else has a tenths place. If I was to add something here, it would just be 90.0. That did not change the value of the number 90, but it did make it look like all the other numbers. Next up, you're going to have 90.3, 91, which once again, remember, is going to be 91.0. And then finally, the biggest one is 91.4. Now that all of my data is in order, we're going to go ahead and make our stem and leaf plot. So the first thing that you want to do every time is go ahead and draw that line to separate the numbers. So now, once again, you got to think about, okay, what am I separating? We can see now we're going to be separating the whole number from the decimal point. Now for each one, all you can ever do over here on the leaf side is have one number. Over here, you could have multiple numbers, but on the right-hand side where the leaf is, you can only put one number. So let's look at our first one right here. I've got 84.3. My whole number is 84, so I'm going to go ahead and stick that 84 over here on this side. Now what I want to show you another way, we didn't do this past time for example 1, but for example 2 I want us to do this. If you remember, I said whenever you're making your stem, remember the stem's on the left of that line, you can only count by ones. So I know I'm going to have to start with the 84 whole number. If I look at my largest number, it's a 91.4. So I am going to have to make sure as I'm going down on the left-hand side that my stem goes from 84 down to 91. So let's just go ahead and count it down. 84, remember you can only count by ones. 85, 86, 87, go ahead and write this down in your notes. 88, 89, 90, oops, it's getting kind of tiny, and 91. Okay, so we are now going to be going through and we're going to be putting the information in. Once again, we started with that 84. On the right hand side, my decimal point is 84.3. So now I can go ahead and go to the next number. I've got an 85 in my stem. If you look up here in the data, my next number is an 87. So I have nothing in the 85. If you remember, I do not want to put a 0 there because then it will look like I have an 85.0 in my data set. But if you look right here, there is nothing in the 85's family. So we are not going to put a 0 there, we're just going to leave it blank. Once again, even if you look at the 86, you can say I don't have any numbers in my data set that start with an 86. So now I'm going on to the next one, which is 87.5. So you're going to put the 87 there on the left-hand side for your stem, and then I've got 0.5 over here for my leaf. Now if you notice, I am not putting any decimal points in there. Whenever you have a stem and leaf plot, you are not allowed to put periods for decimal points or commas. That's why you have your key, because in the end, our key is going to tell us whether it had decimal points or commas in it. So now I'm going to keep going on. You can see there's nothing else in the 87's family. Now I go to my next number, which is an 88. As I look in my data set, there's nothing for 88, so I'm not going to do anything there. I want you to pause the video and go ahead and see if there's any way that you can try to fill in the rest of the leaves on your own. Okay, let's check it out and see if you got the right answers or not, okay? Once again, 88, there's nothing there. Going on to my next one, I've got 89.4. So I know I'm going to have 4 over here. Once again, do not put decimal points in a stem and leaf plot. Up next, 89.7. Now give yourself a little space. You don't want to put it right here next to it and smush it like that. Instead, you'll give yourself just a little bit space so that you know it's a different number. Next up, I've got 90, 90.0. Now remember, you do have to put the 0 there, otherwise it seems like I don't have anything in the 90s family. Next up is 90.3. Once again, give yourself a little space between the numbers. And after that, I've got 91.0. And then finally, I have 91.4. Okay, remember, I am not finished ever with doing a stem and leaf plot unless I have put my key in there. Now remember, with the key, you are allowed to choose any number that you want to. For me, I'm just going to go ahead and focus on this right here. Now, when I look at that, you might think, oh, that's 875. But no, if you remember, you go back to your data set at the beginning, it's 87.5. So you're going to go ahead and start off with writing 87 with a line, 5 equals 87.5. And then I want you to box your key in. Now remember, you could have done any number. Let's say that instead I wanted to do this very first one. Instead, for that, you would make sure you say 84 with a line, 3 equals 84.3. Okay, so once again, you can choose any number in your data set to be your key. All right, so that's kind of how a stem and leaf plot works. Now, we have been talking a lot about mean, median, mode, and range in class, especially with you guys having your project coming up. So I want to do one example before we finish up this video today about those 4 different things that you find with a data set. If you feel comfortable, you can go ahead and try to do it all on your own. The first thing you want to do, remember, before you do anything else, is put your numbers in order from least to greatest. So I know 108 is the smallest. Next up is 490, 502, 502, another 502, and 518. Once again, try to pause the video and see if you can figure out. Remember what these 4 different things mean. If you are struggling with remembering it, you can pull out your notes from 3.1 to help you. Okay, I hope you paused the movie, or whatever it's called, the video. Anyway, Talking about the mean, you have to find the average, so you're going to add up every single number here in your data set. As I add them up and I put it into my calculator, I found that that was 2,622. Now remember, your mean is always going to be somewhere in between the smallest number and the biggest number. A lot of times people accidentally forget and they just leave it as 2,622, but that number does not come in between my lowest and highest data number. Instead, you have to remember when you're finding the mean, you have to divide by the total number of numbers you had in your data set. So you can see right here, I had 1, 2, 3, 4, 5, 6. Just from that, you know you're going to be dividing by the number 6. When I plug that into my calculator, I see that the answer is 437. And once again, I can tell that does come in between my lowest number here and my highest number. Next up is the median. If you remember, the median is the middle number, okay? So this right here, those are on the outside, then you keep coming in. Here you can see this right here is my middle number, okay? Now remember, you could probably easily just look at that and tell what the average is of those two, but in case you cannot, you have to add those two numbers together for the mean. When you add those together, you get 1,004, and you divide by the number of numbers that you added. I added 2 numbers, so I'm dividing by the number 2. When you do that, you will see that you got 502. So basically what that's saying is if there was a number to come right in between those two numbers, it would be 502, which makes sense because both of those were the number 502. Next up is the mode. If you remember, the mode is the number that occurs the most, that occurs more than any other number in your data set. 502 is clearly the mode because it occurred 3 different times. Now the last thing you want to remember is your range. Your range, you have to take the biggest number in your data set, which was 518, and find the difference or subtract the lowest number in your data set. Remember, this is how you show work. You got to put those numbers there so that I understand what it is that you were trying to do. And once again, when you do this, you plug it into your calculator, you see that your answer is 410. All right, so that is how you find the mean, median, mode, and range of the data set. Don't worry about doing these kind of problems. We will talk more about this same idea tomorrow in class. Thank you for listening.